Let's discuss bird's eye view of Elasticsearch in simple terms and what components actually makes the architecture of Elasticsearch. So when you think of setting up Elasticsearch, it simply means creating a cluster to begin with. By definition, a cluster is a collection of nodes, and by default, a cluster is created with just one node. E-commerce setups, you may have different dedicated clusters based on functional domains. For instance, there can be one cluster storing the catalog and all its products in it, and same can be used for searching products in the e-commerce application. Similarly, there can be another cluster storing all the logs of distributed microservices that you have in the application, and you may use it for observability as well as metrics purpose, maybe via ELK stack. Application performance management, also called APM, is another use case. So where exactly the data is stored in a cluster? Answer is nodes. A cluster can have one or multiple nodes. Data is stored as documents, and each document is a JSON object. So overall, entire data is stored in the form of collection of documents indexed together. Now let's take an example of a catalog index of size 6 gigabytes and see how it can be stored in a cluster. As you can see, each node in the cluster has a maximum of 5 gigabytes of memory, which is clearly less than the index size. A logical solution to this is to split the index into smaller parts. And each part can be of 3 gigabytes stored in different nodes. Data within nodes can be further splitted up and stored in shards. By default, each node has one shard configured and you can increase it according to your needs. So our data of 3 gigabytes can be stored in each shard as shown below, where each shard is storing 1.5 gigabits of data. So are there any further advantages to shards other than providing logical data unit? There is one. Shard actually increases performance and query throughput as it can support parallel queries hitting data in each shard. Now let's consider one scenario where one of the node machine goes down due to hardware failure. Clearly, the data stored in that node can be lost forever. And that's where the replica shards are helpful. Replication supports fault tolerance if there is hardware failure of one node. If replica shard is stored on another node, it can be used to spin up failed node again and load the data. For example, in this case, if node 2 goes down, you still have replica shards stored in node 1 that can be used to spin up this node again with the same data. If your instance is running with just one node, there will be no replica shard created since there is no other node available to create one. And it doesn't make any sense to create it on the same node. Same can be seen in health check where status of node is yellow as a warning. That's it for today guys. Let me know what you think of this video. See you soon.